Good morning, students. Today we are going to discuss limit test for lead and limit test for heavy metals. Both are important topic in pharmaceutical and organic chemistry. Limit tests are used to detect small amount of impurities present in the pharmaceutical substances. Now let us discuss about limit test for lead first. Lead is a toxic heavy metal impurity and even small amount can be harmful. Lead may enter drugs through reagents, water, glass container, or manufacturing equipments. Therefore, pharmacopoeia prescribes a limit test to ensure that lead is within the permissible limit. Limit test for lead is based on the formation of colored complex using diphenyl thiocarbazone, also called dithiazone. Limit test for lead is also known as diphenyl thiocarbazone test. Diphenyl thiocarbazone, also called dithiazone, is an organic reagent that dissolves in chloroform and gives a green colored solutions. When lead is present, it forms a violet or red colored complex with dithiazone. The sample is dissolved in water and transferred to a separating funnel. Other metals like iron may interfere with the reaction. So ammonium citrate and hydroxylamine hydrochloride are added to complex these metals and prevent the interference. So this allows only lead to react with dithiazone. After removing interference, the solution is made alkaline using ammonia solution. Potassium cyanide is added to keep other metals in complex form. Then dithiazone solution in chloroform is added. When the mixture is shaken, lead reacts with the dithiazone and moves into chloroform layer. The chloroform layer becomes violet or red. The extraction is repeated until dithiazone solution remains green. So green color means all lead has been extracted. The chloroform extracts are combined and nitric acid is added. Nitric acid converts lead dithiazonate into lead nitrate. The solution is again extracted with dithiazone. This double extraction ensures that only lead is present and other metals are removed. Finally, the color obtained is compared with the standard solution prepared using a known amount of lead. If these if the sample color is not deeper than standard, the sample passes the test. Otherwise, it fails. The apparatus used in this test is separating funnel. Separating funnel is used for liquid-liquid extraction. It helps to separate aqueous layer and chloroform layer. During shaking, lead complex moves into chloroform layer. After separation, the chloroform layer is collected. So proper cleaning of apparatus is important to avoid error. Coming to the procedure, prepare the sample solution and transfer to a separating funnel. Add ammonium citrate, hydroxylamine hydrochloride and potassium cyanide. Then make the solution alkaline using ammonia. Add dithiazone in chloroform and shake. Allow layers to separate. Collect chloroform layer. Repeat extraction until green color appears. Add nitric acid and extract again with dithiazone. So prepare standard solution similarly. So compare the color of the test and standard. Observe the color of the complex formed. The intensity of color depends upon the amount of lead present in the sample. If the sample color is darker than standard, the given sample fails. If the sample color is lighter or equal to sample, the sample passes. Report should state whether the sample passes or fails the limit test for lead. This ensures safety of pharmaceutical substances. So we discussed the principle of limit test for heavy metals. This test is used to detect and control the presence of heavy metal impurities in pharmaceutical substances. So in this method, heavy metals react with hydrogen sulfide or sodium sulfide to form corresponding metal sulfides. So these metal sulfides produces a light brown to dark brown color depending on the amount of heavy metals present. The sample is first dissolved in acid or alkali to prepare a clear solution. The pH of the solution should be adjusted to about 3 to 4 using dilute acetic acid or dilute ammonia solution. The test is carried out in two Nestle cylinders, one for the test solution and other for the standard solution. The color produced in both solution is compared to determine whether the heavy metal impurities is within the limit. So in this slide, the chemical reaction involved in the limit test for heavy metal is shown. Heavy metals react with hydrogen sulfide to form metal sulfide. The metal sulfide produces a brown color in the solution. The reaction can be written as metal ion reacts with hydrogen sulfide to form metal sulfide and hydrogen ion. So coming to the procedure, take two 50 ml Nestle cylinder. One cylinder is labeled as test and other is labeled as standard. The sample solution is taken in the test cylinder and the standard solution is taken in the standard cylinder. The pH of the solution should be adjusted between 3 and 4 using dilute acetic acid and dilute ammonia solution. After adjusting the pH, the required reagent is added to both cylinders. Both solutions are then diluted to mark and mixed properly. After standing for 5 minutes, the color developed in both the analysis cylinders is compared. So coming to the observation is made by comparing the color of the test solution with the standard solution. The comparison should be done by weaving the solutions downward over a white surface. If the color produced in the test solution is not more intense than the color in the standard solution, then the sample passes the limit test. If the color in the test solution is darker or more intense than the standard, then the sample fails the limit test. This indicates that heavy metal impurity is more than the permitted limit. Thus, we studied limit test for lead and limit test for heavy metals, including principle, the reagents, apparatus, procedure, observation, and finally result. So this test is important to ensure that lead impurity is within the safe limit. Thank you.